Looking for a cutting-edge master's program in business analytics? In the Central European University in Vienna, we offer an impactful one-year English language program accredited in both the US and Austria. Scholarships are available if you apply by the 4th of February. In the program, you will master coding, data analysis, machine learning, and data engineering, along with business intelligence and agile project management. Beyond core expertise in these fields, you'll also practice harnessing AI in coding, analytics, and design. You'll complement your studies with real-world experience through use case seminars and a capstone project with an industry partner. My name is Gábor Békés. I'm an associate professor here at the Department of Economics, and I teach a series of data analysis courses. Hope to see you in September.
Thanks everyone for joining today, and at the very same time I'm also sorry that this talk is not about data analytics but rather about the underlying infrastructure, and I will focus on how to utilize cloud compute resources in the most optimal way, which will be still hopefully useful for at least some of you. Let me start. Why would we want to do that, like utilizing all the cloud compute resources? Because the cloud is like the sea. There's unlimited resources, pretty cheap, and we should just not bother with the infrastructure, just focus on models and so on. But at the end of the day, what I've seen, and I'm pretty sure everyone in this room can agree to, that the data science jobs have very diverse compute needs. Like when you are running a SQL query, that's super lightweight, except for that poor database, right? But your laptop and the server you're running this query doesn't need a lot of compute. In many cases, we run R or Python scripts, which might be lightweight as well, like training a linear model, doing some API integrations and so on, or it might require a few hundred gigs of RAM to train a hierarchical model, or you might need a plethora of GPUs for some image processing or whatever, or you might need a couple hundred CPU cores because you are forecasting time series on a bunch of different metrics. And honestly, scaling the data science infrastructure is not straightforward at all, although there are a lot of different solutions for these problems for like a decade, and we have tried to use some of these for the data science team, like ECS, AWS Batch, Kubernetes, solving all your problems, right? At the end of the day, for model training, I think that's not the case because of the very diverse need for different jobs. And you will be over-provisioning, you will have a lot of errors because you're trying to deploy two very different services on the same server, and it will be just a mess. So let me jump back here. At a previous role, we solved this problem by a couple hundred lines of Python script, which were very closely monitoring all our Docker containers, like logging every second the CPU usage, RAM usage, and so on. We had around 4,000 containers running every day. And we took this data and figured out which server might be the best to run that job, and we allocated a single server to every job because cloud server pricing is linear, just like its resources, so it doesn't make any sense to put two services on the same server. And anyway, we managed to build this few hundred lines of Python script which worked very, very efficiently without failing and over-provisioning and spending a lot of money. It turned out to be useful for some other folks at the company as well, so we open sourced. It was called CloudPerf, and it worked very, very nicely. But still, the development of this product was decided by the business requirements of this company. So I was hoping that we could generalize this more and not tie it to the advertising technologies requirements. So last year I applied for some EU funding, got 150,000 euros so that we can extend this a little bit with a bunch of hopefully useful features that I will share in a bit. And this is how Spare Course was born like a year ago. And to keep it short, it's a collection of open source tools. We have database definitions, documentation, some ETL tools like how you can collect your own data points about cloud vendors. We also manage infrastructure and databases so that you do not have to run our ETL tools, but you can just use our database dumps, public APIs, SDKs, so that you can search about cloud servers. We also provide Python tools so that you can start those servers very easily. You do not have to bother learn the Azure way of starting servers versus AWS or Hetzner or whatever, but you have a standardized tool to do that. And we also have a software as a service, or rather a container as a service in the works, so that you do not even need to do any vendor engagement. You just say that I want to run this job, here's my money, and please solve my problem, and we will be happy to do that. Some stats about the project. It's a bit outdated, but we integrated 5.5 cloud vendors so far, which already includes more than 2,000 servers. So just imagine you have a data science job and you want to figure out which is the optimal server to run this on. You have more than 2,000 options. Also, these are not always very comparable. Like AWS is saying different things about their server compared to Azure and so on. Also, these guys are living in more than 300 availability zones around the world. Their pricing, as you can see, is more than 250,000 that we are updating every 5 minutes. And we are also not only just looking at these servers, but we have started all of these and run different benchmarks that I will share a little bit more about that in a bit, which is almost 1 million benchmark scores that we also keep up to date. The easiest way to get familiar with this data is going to sparecourse.com. We have a homepage where you can filter for these servers, see some of the metrics that I mentioned. You can click on those and you can see some more details about the servers, pricing, including spot, on demand, across all the regions, AZs, and so on. Some benchmarks, and I just included a few like compression algos, block ciphers, hash algos from OpenSSL, and so on. We are running Geekbench, Passmark, and a few other industry standard benchmarking tools on every single server, making this data public and free for everyone so that you can decide which server makes sense for you. We are also collecting data on the server with some hardware inspection tools, like you can see the level 1, level 2, level 3 cache amounts for the CPUs and a bunch of other data points as well that I will try to cover very soon. We have comparison tables. You can generate plots to compare any combination of those 2,000 servers. For computer or programmatic view, we have APIs, SDKs, so that you can search. And yeah, hopefully I can just scroll down here so that you can see the depth of the data that we provide. Unlike on the vendor homepages, we provide pretty detailed information about the GPUs. Like you can see the BIOS version, firmware version, which might be pretty useful for some machine learning cases. Again, this is a collection of open source tools. So if you're interested, please check out. Everything is on GitHub, on PyPy. You can use this. And I know in 10 minutes, I cannot do an interactive Q&A session. So I prepared a few slides, like you might ask, which was our biggest challenge? Just like with any project dealing with GPUs, it's quotas and actually capacity issues. So it took like 3 months to get some of the vendors to get us approved to run their $250 per hour server so that we can benchmark. And at one point, we actually reached the quota update request quota, which I found pretty interesting. Next question, thank you for that, is why are we just not using ChatGPT? Because these LLMs are solving all the problems. I would like to highlight that we are not only collecting data, but generating as well, like running the benchmarks. And also look at this poor guy. Like it searched the whole internet, actually found the exact number of HDDs in the server, but doing the multiplication was just too difficult. So there's hope that there's a good usage for SpareCores. And last question from you, did we actually burn 150K on this? And yes, we did. I was hoping that we will not, but we did at the end of the day. I wanted to spend most of the money to build a container as a service, but Honestly, this is a huge mess, and I'm not speaking about data quality, but even data availability is a huge issue regarding cloud resources. And I know time is up, so I will not go into the details, but there's one thing you might remember from this talk. There's a clean data set out there about cloud servers that you can use, so please look that up. Of course, I'm not doing alone. I'm in a good company, as you can see from the profile pictures of my friends working on infra and the web front end, and also me doing a little bit of everything or nothing. It depends on their perspective. And yeah, I will just stop here. Please follow us or look up the homepage, or let me know if you have any questions. And I'm actually stopping here. Thank you very much.